All right, the equation for electric potential. If we know that there is some charge Q and there is a distance of 0.02 meters, and that the electric field at that distance is that value, we just use the equation. We know the electric field is KQ over R squared. So then we can say Q is equal to E R squared over K. Sweet, thanks. Oh.
Thank you.
Thank you for the reminder. If we know Q, we can say electric potential is KQ over R. So then you just plug that in and get your answer. Now what you can also do, if you want to, I mean for this, you mean? No. Electric potential is just Q over R. Now if you wanted to play the tricky algebra game, okay, what you hopefully can remember are some of these weird combinations. For example, E is F divided by Q, right? And then potential energy is F times R, right? And let's see, is there another one? Yeah, and then electric potential is E times R. So all you really have to do is go ER. But this is, I mean, we find Q, then we can do the other ones as well.
What's F and E equals M Q?
Oh, just force. That's the force from an electric charge, or the force on an electric charge by another electric charge. So this, right, this is going to say our electric field is 45. And this is going to say, what does our electric potential become? This becomes, what? Well, 2 would be 45, so 0.45? Is that right? Does this come out to be 0.45? I think right, because I moved the decimal over twice. I'm just going to say that. 0.45 volts. That was awesome. I said 0.5 and I wrote 0.4. So 0.45 volts. Correct me if I'm wrong. I'm just going to go with that for now. And then that means our electric potential will be 0.9 volts. Right? So just do the math. Right? Here we have, we know that, we already know that the electric field based on this charge, yeah, you know R already, and then we did the math over here so we can come up with Q. So then you can just take these two things and solve. And if you're not sure what I mean, I'll go back to white here. Do you see that the E, we know what E is, we're looking for R. So right here, if I solve this for R, I'm going to get R is the square root of KQ over E. Of course, this you have to actually calculate. So I don't know, plug that in your calculators, tell me what you get. Actually, I can plug it into my calculator. Okay, what was E? E was 22.5 newtons per coulomb. Oh. So this right here, right, we're trying to find Q. So we have to use our original E with our original R over K. So it's our original E, which was 22.5. Crap, what did I just say? Oh, E times D over K, is that what I said? E times R, which is 0.02 squared,
Yeah.
divided by K, which is 9 times 10 to the 9th.
Is it always going to be that?
Is what always going to do that?
K is always going to be that.
Yeah, K is a constant. So that's 1 times 10 to the minus 12. Oops. So 1 times 10 to the 12, it's really, what is that? Nano, what's after nano? Pico. Yeah, that's 1 picocoulomb of charge. Yeah, or 1 times 10 to the minus 12 coulombs of charge. So that's how much our charge is. Now, we can just solve both of these. We know that R is going to be KQ over V. You know Q, you know R, you know E, you know V. I'm sorry, R, excuse me. You know Q, you know E, you know V, and you know K. Boom, plug it in, get your answer.
E45 or 0.4?
What's that?
E45 or 0.45?
This is 45. Remember, because it asks for what is the radius when the electric field is double. Now, so we get 0.014 meters here. What do we get right here? So it's, again, it's going to be, oh, this one's even easier, because this one becomes 0.009 over 0.9. So that's going to be 0.01. So that's what it is, 0.01. So basically that means half. And do you see why? Is there a squared term on the bottom? No. So if you want to double the V, what do you do to the R? Cut it in half. Because if you put a half on the bottom, that becomes a 2 over here, right? But over here, right, when you look at this, if you want to double this, what do you have to do over here? Because you're squaring R, right? You have to multiply the bottom by the square root of 2. You see that? Because then when you square the square root of 2, you get a 2 on the bottom here, which doubles it. No, I'm sorry, that's not right. Like multiply by, or sorry, you have to do, this we had to divide the bottom by 2. This one we have to divide the bottom by the square root of 2. It's the same logic as this, just we have to include the square, that's all. But whatever, you don't have to think about it like that. This works perfectly well. So we did this work in the beginning, and we had to use it to get the end here. And I'm still talking.